That's the great thing of this being a pilot and a demonstration project. First 2 turbines in federal waters. We're really working to understand what's out there, what's coming about, and what can we deploy when we start construction so that we can produce the maximum amount of power for the turbines that we have out there.
This is EnergyCast, and I'm Jay Downhauer. Today we are talking about offshore wind farms. There are currently 7 wind turbines in the Atlantic, and 2 of them belong to my guest. But based on their performance, they plan to build many, many more. It's called the Coastal Virginia Offshore Wind Project, and it's a first for 2 reasons. One, it is the first commercial project to be built in federal waters, in this case between 27 and 40 miles offshore. Second, it's currently the only project leased and developed by an electric utility. That might sound a little strange, but according to the existing lease documents with the Bureau of Ocean Energy Management, all other offshore wind projects will be developed by foreign companies or consortiums you've never heard of. The CVOW, as my guest calls it, would eventually comprise 180 14-megawatt turbines. That's 2.6 gigawatts of installed capacity. Taken as a single power plant, it would be the 20th largest in the United States. My guest leased approximately 130,000 acres in a 10 by 13 mile rectangle off the coast of Virginia Beach. One of the questions I asked my guest was what happens on the days when all that wind stops blowing. Construction on the project is expected to begin in 2023 and run through 2026. For construction of the 2 turbines out there right now, my guest says they were hampered by available vessels. Turns out there are no U.S. flag ships that can install turbines like these. To comply with a 101-year-old law called the Jones Act, the ship that could perform this work had to steam back and forth from Nova Scotia to install the demonstration units. My guest says they are now building a $500 million ship, which they're christening the Charybdis, which will be able to move between U.S. ports. My guest and others from the company told me they were wading into new waters on this project, particularly when it comes to regulations and permitting. Their regulatory head told me they can only drive the pilings for these turbines between April and November because the rest of the year could harm marine life like migrating whales. It was surprising to me how new these projects are to the United States. Europe has over a decade on us at the time of this recording. Yet it looks like we will soon see at least half a dozen projects like the CVOW spinning off America's shores. It's just the beginning of an offshore wind revolution. My guest today is John Larson, Director of Public Policy and Economic Development for Dominion Energy, an electric utility based in Virginia. This was an incredible opportunity that I'm getting to share with you. I've been aware of this project for some time now. The 2 test turbines were installed in 2020. I'd been in touch with Dominion about visiting the project since the beginning of the year. Once COVID restrictions eased and the weather was a little warmer, Dominion invited members of the press to come out on boat for a media day in the middle of June. We set out from Virginia Beach that morning. The trip took about 2 hours to reach the turbines. On the way out there, several Dominion Energy team members briefed us on the project, their plans, and what they've learned so far. When we got out there, the boat captain knew exactly how to make the biggest impact. He motored us directly under the blades. It felt like they were going to take our heads off, and you could hear the whooshing every time these 200-foot-plus blades made a pass. I took video, but none of the audio came out. It was windy that day. Go figure. John and I connected about a week after the boat trip, once I was home and able to make a few notes. I hope you enjoy my conversation with John Larson. We're here with John Larson, Director of Public Policy and Economic Development for Dominion Energy. And John, this coastal wind farm, we got to see it. One of the things that's been discussed is, are there challenges securing leasing space? This was discussed way back in episode 65. It was a conference that I hosted with NAYGN. I had a Dominion representative on there, and he had said that, look, despite what you might think, there isn't that much room out there in the sea. What were some of the challenges for Dominion?
Yeah, let me start with sharing a little bit about the Bureau of Ocean Energy Management. I'll refer to them as BOEM going forward. As BOEM begins evaluating potential wind energy areas, they work with states and various stakeholders to really conduct detailed environmental, societal, Department of Defense, mariner and fishery analysis before they decide to move forward with an auction process with wind energy areas. There's a lot of consideration that goes into that selection before they do get into that auction. And it's really an effort to make sure that they're good target areas and that they make sense for all the stakeholders that are involved. And another issue has just been as the industry's getting started, and I don't know that I'll call it a challenge, but as the interest and commitment to the U.S. offshore wind industry has really accelerated, we've seen a big change in the competitive auction process that BOEM conducts. We've really seen the winning bid values increase, Jay. The first 7 lease rates, really with the exception of one, went for less than $1 per kilowatt. And really based on our estimates of what the lease cost have been in the current class of turbines, we're seeing $40 to $50 a kW. And that's pretty interesting. So as the Biden administration advances and adds new lease areas, we'll have to see how that increased supply versus the demand impacts acquisition prices as well. A lot of factors come into play, getting the right area and then having a cost that works as well.
Yeah, and one of the things that I've heard about is some of the super majors, the oil companies, are getting into this space. It would make sense. They've had some experience with offshore oil drilling. They know how to put things in the ocean. They also probably want to diversify and try to lower their carbon footprint. So do you think maybe that kind of competition is also driving up some of those prices for the lease rates?
To date, most of the existing leases have really been driven by European developers or American development companies moving forward into offshore wind. We're the only utility to date that has decided to move forward with an offshore wind project. I can say we'll just have to wait and see what happens. I've seen some of those similar announcements, Jay, that it looks like there is interest from some of those other industries in exploring their opportunities for engaging in offshore wind energy generation.
Sure. And getting back into the lease space, it was funny. One of the things that we'd been told was you wanted to situate the wind farm in between shipping lanes. You didn't want large ships going in between. I think they said that there were shipwrecks and all kinds of stuff there on the ocean that you also had to consider when deciding where to place these turbines, right?
Yeah, that's exactly right. And part of looking at a lot of the maritime and sea transportation that goes on really takes part in that BOEM initial analysis. So if you look at the coastal Virginia offshore wind energy area, it's really nestled in between the two major sea lanes as vessels exit the Chesapeake Bay. You mentioned some of the historic wrecks that may be out there. We do have a little notch in our wind energy area that is called the wrecks. And it's where there's a number of old wrecks that fishermen use, and it's also from a historical perspective that's excluded, and we will not be putting any type of cabling or wind turbines or offshore substations in that area.
Well, speaking of substations, I've been a project manager on the transmission side, and that's a complicated part of this project that I don't think most folks will recognize. How are you tying all these turbines to the shore using a transmission network?
Yeah, I'll go through that and I'll say, Jay, we share some common experiences. I spent a little over 3 years in our transmission construction for lines and substations. It was a great experience and just a great team of people to work with. But turning to the CVAL project, there'll be nearly 180 14 megawatt Siemens Gamesa turbines in that 113,000 acre lease area. That's about 85,000 football fields. It's about 13 miles across east to west and 10 miles north to south. To accommodate collecting the energy from those turbines, there'll be lower voltage inter-array cables that are buried in the seafloor that serve as, I guess I'll call it a collector system to bring the energy from roughly roughly 1/3 of the offshore wind turbines to a offshore wind substation. There'll be 3 of those substations for the 180 turbines, so roughly 60 turbines serving each offshore wind substation. And then from the substation, there'll be export cables. Again, they'll be buried in the seafloor that will bring the power to a vault about a half-mile offshore. And there from that vault, so that there's no disturbance of the nearshore ecosystem, you use horizontal directional drilling, go under the beach and come out behind the beach, and then start the land or on-site aspect of connecting offshore wind power to the transmission grid. And in our case, we'll come ashore, and then the power will travel about 13 miles over 230 kV lines till they get to a substation where they'll be able to interconnect to the 500 kV system and take that power to Virginia's homes and businesses.
I'm curious, I was surprised when I heard that you were burying the lines under the sea floor. I haven't done very much undersea transmission. So is that typical? Was that a requirement?
It's a pretty common practice. And if you think about it, it's really from a safety and a reliability perspective. If you have the cables just laying on top of the seafloor and say a vessel comes along and drops its anchor, they could damage those cables, which would interrupt the power supply coming from the offshore wind turbines. It's very common to have those buried in the seafloor as you come in, and it eliminates obstructions of anyone that might be fishing in the area and those types of things.
John, I had a chance to speak to your permitting lead, Scott, while we were out there. He said there was a lot of thought that went into the decision to use a single pylon for each of these turbines, especially when it comes to disruption of marine life. For instance, the pounding driving the pylon into the seafloor is disruptive. It makes noise. So how is a single pylon for an offshore turbine the best?
That's a very interesting question. And Jay, I initially worked on the pilot project when I was in our Alternative Energy Solutions group as we were evaluating designs. And we evaluated several different designs, including the jacket designs, which can have 3 to 4 pilings for each turbine to create that strong foundation. It turned out that that monopile, or that single foundation, was more than adequate to withstand the loads that we would see with the wind turbine. It really made it pretty simple if you think about it. The lower number of pilings, less noise, less time required to do the install, and also lower cost. And let me tell you one more thing. For one of the foundations, we employed what's called a double bubble curtain. And so that was a vessel that circled the installation vessel as they put the piling in. And on the other turbine, we did not use the double bubble curtain. And we found that that curtain really produced a measurable and meaningful decibel reduction for the aquatic species in the area. And we've shared that information, of course, with our regulators as well as other offshore wind developers. So it'll be interesting to see how that information proliferates through the industry. But a lot of opportunity to keep learning about this. And that's one of them that came to mind when you asked that question.
Yeah, so many considerations. Now, you mentioned the ships, and I wanted to get into this. This was something that I kind of had a little bit of a debate with your guys out on the boat, but we were also told how much red tape you had to go through with the ship that you were using to install the turbines. There are no U.S. flag ships that can currently do that kind of work, and that's a problem, but you have a solution to that, right? Can you kind of set that up for us?
Yeah, you're exactly right, Jay. Installing those pilot turbines was quite a challenge. I'll say, first off, it occurred at the height of the COVID pandemic. At this time in the United States, there are no Jones Act compliant vessels that are capable of installing wind turbines. So for the pilot project, we actually had to source those vessels from Europe, and they could not make a port call in the U.S., so they went to Nova Scotia, Canada, where the turbines were staged, and then traveled all the way down to the project site to do the installation. Needless to say, as we've gone through the pilot project, we've learned so much about permitting, installing, and operating turbines in the federal waters off the coast of the United States. And that really led Dominion Energy, Inc., the parent company, to move forward forward with commissioning the construction of Charybdis, and that's a Jones Act wind turbine installation vessel. So it will be capable of installing this class of 14 megawatt turbines that we plan to deploy for the CVAL project. And also it will be capable of supporting the installation of the next generation of larger turbines that are in development by the OEMs. It's really a challenge because even beyond the wind turbine installation vessel, we need other vessels that are Jones Act compliant. And Great Lakes Shipping just announced a Jones Act compliant vessel that will be able to get the scour rock or the protection stone is placed around the base of each turbine so current doesn't erode the seafloor around the turbines. So that won't have to be sourced from Canada. You'll be able to use U.S. stone that is put on board the vessel at a U.S. port, which will go a long way towards helping to reduce the cost of installing projects and give greater surety and reduce risk that you'll be able to get your project done on time and on budget.
Yeah, the Jones Act, the thing I was asking on the boat was that's an awful lot of pain to go through going back and forth between Nova Scotia when you're 25 miles or so offshore from the project in Virginia. There wasn't a way to maybe ask for an exception for the Jones Act because there's no such vessel that's U.S. flag that exists. I was saying, why don't you just pay the fine? That would almost to me seem as affordable as going back and forth from Nova Scotia.
Yeah, I know specifically for Dominion Energy, we just would not knowingly violate a law, whether the plain written language or the intent of it. We were really working hard to come up with what's the right solution. There's also a challenge. Europe is on a tear to build additional offshore wind. Having the surety the vessel would be available for our 3-year construction period was a big concern. That's another key part that led the parent company to commission the construction of the Charybdis, because if you don't have that vessel, you can't be successful. And in fact, that challenge has been so great. You may have seen a recent press release that 2 other developers, Ørsted and Eversource, have contracted with Dominion Energy Inc. to use the Charybdis to install their projects. They are ahead of us in the BOEM queue and will be constructed before CVAL. And so they'll actually be the first 2 projects up off the coast of Rhode Island. They'll be installed, and then the vessel will come down and do the installation for the CVAL project. So there's a lot of demand for this, and we're really pleased that we can help advance the industry as we go forward with the construction of the vessel.
Yeah, that was also really exciting, this idea that the vessel's not going to be used just for your project. It ain't going to sit idle, right?
No, it won't.
Getting more into the nuts and bolts, how do you think the maintenance schedule is going to compare offshore to all those land-based wind farms?
As you can imagine, there are some very similar maintenance routines, right? They're wind turbines, towers, nacelles, blades, and their control systems, generators, and all the electrical and hydraulic aspects that go with that. But think about this. These turbines are offshore in a marine environment. There are a lot of additional inspections and maintenance that has to take place. Onshore, you don't have to have an unmanned submersible going and doing video inspections of your foundation and the scour and the cable routing. Think about this. The crews that are going to be out there 40 miles offshore working on the most distant wind turbines, they don't have the luxury of jumping back in the truck or the van and running to the shop or Lowe's if they don't have a part with them. So there's going to be a lot more rigor planning your day and making sure that you have all the right equipment, and a lot more predictive and planned maintenance that's well choreographed, because you want to take care of any issue. If you see any variance in operation, you really don't want to have to do major repairs 40 miles offshore in a marine environment. They'll be very similar, but there's some of those additional complexities that come into play here.
Yeah, that idea of having to go make a Lowe's run rings so true. When I was working in an oil field, we go to these leases out in far west Texas, and it's like, all right, you got everything right. And then the guy would forget a 1-inch PVC collar, and then it's a 4-hour round trip. I can understand that. Are the maintenance guys, are they going to be based onshore, or are you going to have a ship offshore in the area?
Yes, we're continuing to develop and optimize our staffing plans, but currently we do envision a 2-week on, 2-week off rotation for the maintenance team. They will be housed on a service operations vessel. It's a floating Holiday Inn, if you will, right? It's going to have berthing space, a galley, obviously workout gym area. It's even going to have an entertainment area with the capability of showing movies like you may see in one of these fancy home theater rooms. And then we'll have several crew transfer vessels. If you will, they're the Uber of the network, right?
Yeah. One of the things they talked a little bit about is some of the characterization you're still doing with the wind resource that's out there in the Atlantic. We always see these heat maps, the little color maps that show where the good sun resource or wind resource is, but maybe that characterization isn't as detailed as those color splotches suggest on maps. So how much characterization has been done in the Atlantic about how much wind resource is really there?
2 words come to mind when you ask that question, Jay: thorough and rigorous. It really begins, I'll be honest, with BOEM's initial assessments. Obviously, they don't want to put a lease area out there that doesn't have good wind resources or an area that continually has really terrible sea states. You wouldn't be able to construct and operate efficiently. So a lot goes into it. But then as a developer, we step in and the in-depth environmental, geotechnical, geophysical, the maritime for sea states, and then the weather data is just almost overwhelming. They're often multi-year studies. You put a Met buoy out there to collect the data, and then of course it's provided to your turbine vendor, but also it's included in the applications of the federal and state permitting. So I think last year we had 7 vessels out there collecting data as well as Met buoys. We're just about to wrap up a lot of those studies as we look at the characterization of that wind energy area and the transmission route to get on shore.
Yeah, we were also pointed to some devices out there that were taking LiDAR data. I love LiDAR. LiDAR can do so much. They said it was collecting data on the waves, wind, you name it. I take it, even though BOEM has done quite a lot and there was a lot of research beforehand, you guys are taking readings now during this demonstration, right?
Yeah, that's the great thing of this being a pilot project and a demonstration project. First 2 turbines in federal waters. So let's get that data, and it's shared with the community overall as far as developers and regulators. But your question really makes me think, as you look at the advancements that are going in the computational capabilities, we can gain even better insight in the weather and sea conditions, and not just right there at the turbines, but even from satellite data and other sources, so that we can do a better job of working with the complex algorithms that control the turbines to really make sure that we have safe and reliable operations always, with that constant eye towards maximizing the turbine output. So to that end, we're really working with universities and vendors to understand what's out there, what's coming about, and what can we deploy when we start construction in 24 and finish up in 26, so that we can produce the maximum amount of power for the turbines that we have out there.
Sure. You said 26, which is the date Dominion, I think, is planning for all of the turbines to be installed. This is kind of getting a little bit tougher questions here. We were told the turbines would be good for, they expect, about 25 to 30 years. And I'm sure you hope to maybe get more out of it than that. But 25, 30 years gets us to about 2050, when Dominion and other utilities have made all these net zero carbon pledges, right? So I assume this is the most prime wind resource you have. So what happens to this wind farm after that?
Yeah, so, that's a really interesting question, because in Europe, we're now seeing turbines easily begin to make 30 years of service, right? The first ones went in 30 years ago and they continue to operate. A lot of advancement in size and technology since then, but the leases have a 33-year operational window that you basically have to get in and get your project done. And currently, the way the leases are structured is that at the end of the lease, the developer must decommission the project. But I'll say that's a long ways off, and who knows what technology advances will be available, repowering or other beneficial reuse. But no matter whether you do decommissioning or beneficial reuse, whatever happens is going to go through the same rigorous reviews that we had during the development installation of the project to begin with. And as you look at it, there's so many different technologies, and we mentioned earlier additional wind energy areas that we would expect based based on the current administration and hopefully future administrations being able to develop. We'll have to see what BOEM decides to do with the leases, if those assets are still able to produce power or repower them in a very effective manner to continue to provide that no emission clean energy. But nonetheless, Dominion Energy, just like any other utility, works to take the long-term view to develop their integrated resource plans. We'll continue to evaluate offshore wind and the options with that as we go forward, and we'll look at what types of technologies are emerging as well at that time.
Yeah, I'd imagine that even after those 30 years is up, you would want to still use that. That area is just so perfect in so many ways. You certainly wouldn't want to abandon it.
Yeah, and that's a question is what will BOEM do with that when the lease is up with the original lessee? Will they allow you to auto-renewal it? We haven't ever done this before in the U.S., so we don't know yet, and we haven't reached that point. It will be really interesting to see how that proceeds.
And look, one of the biggest challenges I could have seen out there was that you will have a 2.6 gigawatt facility, all the turbines taken together that are spinning based on the weather. And that's bigger than all but 2 nuclear facilities in the United States and would be, once it's complete, the 20th largest power plant in the United States. So what's the plan to back up that much power at once whenever the wind isn't there?
That's becoming a very frequent question, and that's a great piece of research, and I hope you don't mind if I plagiarize from you occasionally about the 20th largest plant, and it certainly will be our largest generation asset with nameplate capacity. Here's how you make sure that you can continue to provide reliable energy supply, and that's through a diverse generation portfolio. Think about it, I'm 59, so I'm going to say in the early part of my generation, you had diverse generation portfolios. Nuclear, coal, natural gas, and hydro were really prevalent since really the 70s, right? And as society transitions to the new clean energy generation standards, utilities, being responsible energy partners, are going to move forward and respond by deploying various renewable energy generation technologies to make sure that we have that same level of reliability that we've seen in the past for our customers. That means we'll have diverse generation portfolios going forward. Nuclear, on and offshore wind, solar, you'll still have some natural gas there, and hydro. And keep in mind, we talked a moment ago about new technologies in development, and being a chemical engineer, things such as hydrogen and carbon capture are very interesting to me, and there's a tremendous amount of work going on globally of how to transition to a hydrogen economy. I'm sure there are other technologies that we haven't even thought of as society that'll be pioneered that are likely to enter that generation mix as we go forward to assure that we keep that diverse portfolio and do it in that zero emission perspective.
Yeah, I got to see Dominion's pumped hydro facility in Bath County back in episode 60. And I know that Dominion, I think, is still working on possibly building a second one. That might be another option as well, is bank some up in that pumped hydro.
That's correct. And those are great facilities. They're, in essence, if you think about it, a gigantic battery and great opportunity to take the renewable energy that may be produced at non-peak times and store it and then make that energy available during the peak times to serve the customers.
And then, John, finally, where do you go from here? Are there other areas near Dominion's territory you're planning to develop offshore wind? Would you do it concurrently with this project before the end of 2026? Would you go out further or maybe closer than that zone that's being pinpointed near Virginia Beach?
We're really anxious to see where the current and future administrations take offshore wind energy area leasing and how BOEM moves forward with identifying and auctioning those new lease areas. And certainly, if you look at the Virginia Clean Economy Act, which was enabling legislation for offshore wind and the solar and storage and the renewable portfolio that's been presented, it'll be subject to SCC approval, but knowing that the act calls for 5,200 megawatts of offshore wind, if the opportunity arises, I would envision that Dominion Energy would have a really keen interest in exploring the prospect of delivering more zero emission offshore wind energy for our customers. So certainly we would take a look at it and see how we could move forward if the opportunity arises.
Well, I can tell you from just one of those passengers on that boat, if 2 turbines was probably the most impressive thing I've ever seen, I can only imagine what 180 at double the size are going to be out there.
Yeah, it's very unique and it's very impressive. And the turbines you saw are actually taller than the Washington Monument when the blades are sticking straight up. And the newer 14 megawatt class turbines will be 200 feet taller. So, really large wind turbines erected 27 to 40 miles offshore. And you think about the benefits it gives and then getting that power back in, it's quite an engineering and operational feat. And we look forward to bringing it to fruition and delivering that energy.
All right, John Larson, Dominion Energy, thank you so much for your time.
You're welcome. More than glad to do it. And if there's another opportunity for us to talk about offshore wind, be glad to do that, Jay.
That was John Larson, Director of Public Policy and Economic Development for Dominion Energy, the only electric utility developing an offshore wind project. On the way back to the marina, we passed a nuclear submarine. I'd say we were about 600 yards away, but close enough to make out a sailor who popped out from the top and waved back at us. I want to thank John for his time, as well as Jeremy Slayton and the entire Dominion team for making this trip possible and sharing with us. You can find plenty of pictures from my trip and for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 118. Be sure to join us next week when we explore the latest developments in scrubbers. Until then, I'm Jay Downhauer. We'll see you next time.